So let's use de Moivre's theorem to find the fifth root of a complex number. So here we're given this complex expression and we're trying to find z to the power 5 or z. So the first thing you want to do is to take all these numbers to the right, so you have a clean expression for z to the power 5. So this is your rectangular form. We don't like to have these surds in the denominator, but nevertheless, this is the rectangular form. You want to convert this to polar. That means an r theta form. So if you sketch a quick Argand diagram, that just means a diagram where the horizontal axis represents your real components and your vertical axis represents your imaginary components. So you have a negative 1 over root 2, that's your real, and a positive 1 over root 2, that's your imaginary. So this is z to the power 5. And the magnitude is r, so this length, which would be the square root of this squared plus this squared. Okay, so that's how you would find r, and that gives you 1. And you'd find theta. Now remember, theta is the anti-clockwise angle from the positive real axis. So theta is this angle here. So I guess it would be pi minus this angle here. And this angle here is the inverse tangent of the imaginary over the real. And this are the same, so it's the inverse tangent of 1. The inverse tangent of 1 is pi over 4, so pi minus pi over 4 is 3 pi over 4. Remember, with doing this in radians. So now we can express z to the power 5 in polar form. So we can rewrite it like that, where the angle is here and the magnitude is here. So this 1 is necessary. You can't just remove the 1 and say, oh, we don't write coefficients of 1. No, this 1 is necessary because it is the r in the polar expression. So both these numbers are necessary. So that's z to the power 5. Now, if you want to write this in sine cosine form, you can do that. All you need to do is convert this into a cosine and a sine, where the first term will be your r, so this is your r, and this here is your theta, and we know that cosine is periodic with a period of 2 pi. So you can add multiples of 2 pi to the cosine without changing it. So if we have some integer k, where k is 0, 1, 2, 3, all the way until n minus 1. So n minus 1 is 5 minus 1, which is 4. So we're allowed to add multiples of 2 pi to the cosine without affecting it, in radians, obviously. So we would do the same for the sine. This would be our theta, and we simply add multiples of 2 pi. And we can simplify that a little bit by taking pi as a common factor, replacing 3 over 4 with 0.75 if the question requires it in decimals, and that's your 2k. Now, depending on the question, you might be asked to use n or m instead of k, but that's fine. And it's exactly the same for the sine. So this 1, you'd write there. You've got your cosine, you've got your sine, and remember, you've got your j So that's z to the power 5. Now, if we go back to our r theta expression, we can rewrite z to the power 5 and find the fifth root to find z. So we can write the fifth root as power 1 over 5, and that's perfectly okay. Then we can use de Moivre's theorem. De Moivre's theorem says if you're ever looking for the nth root, and we're looking for the nth root, you can rewrite it like that. So I will do exactly that. I will take the r and replace it with 1. I'll replace the n with 5, so that's my n. So these are my n's. I'll then replace my theta with 3 pi over 4. So this is my theta. And I'll do the same here. This is theta. And that's it. You can simplify this by, 1 to the power anything is 1, so no need to write that. Or depending on the question, you might need to write it. And then you can simplify this to make it 3 pi over 20. And then you can take pi as a common factor. And that leaves, 2 over 5 is 0.4. And 3 over 20 is 0.15. And pi is a common factor. So if the question is asking for it in this form, it could be that the k needs to be represented using an n or an m. It doesn't matter. So this is the general form, and you would then substitute k equals 0, 1, 2, 3, and 4 to find your value of the roots z1 to z5. And this would be your general or your final answer.